Okay. So I have my multimeter here. I tested for continuity. This is the output of this switch here. These wires go directly into the yellow cable that gets plugged in on the outside. So I get continuity from these outfeed wires out of the switch, from the fuse. Fuses are good, so I get continuity from down here to the outside pins. I get continuity into the fuse from these two black leads, but not this red lead. You test up here and you test down here, nothing, but the fuse is good. It makes me think maybe the switch is bad. Okay, I'm gonna test it for continuity again. So I'm coming on this bottom lead and the top lead, nothing. It's deader than a doornail. And I'll see if I go from the fuse to this bottom lead, I get continuity. Not sure if you can hear it beeping or not, but it reads down to 0 ohms. Yeah, nothing through this top pin to the bottom one. We'll move to the second lead right here. Continuity. Move to the third lead. Continuity. I'm gonna go ahead and try to pull this out, unhook the wires, and see how they are. The red, and then the two blacks. The one with less of a curve goes to the outside, and then we have wire H1 on pin 1 and H7 on pin 3. There's nothing on this pin. This goes in here. This operates the slide back and forth. But right here, you see a lot of heat damage. It's all bubbled up right there. See up in here. I'm really wondering, since you have 3 inputs and only 2 outputs, if you could just move your red wire over one and then put your H1 or T1, whatever it was, here. I don't know how else to open this up anymore. I don't know. I guess maybe I could take that section out. I don't know. I'll see. So here's your in. Pulls. Goes to the fuse holder, through the fuse holder to the fuse, and you're out. Out ain't that bad. The in is really fucked up. See all that? These slide between all the pins. This was the red wire that went through the fuse to H1 or T1, whatever it was. You can see the amount of carbon and just ate up copper, eroded copper. Heat damage on this. So I'm gonna clean this up. This is a pretty straightforward switch. Each of these three have their own fuse and output. Okay, here's the burned up lug. I'm gonna get me some sandpaper and clean up all these contacts, reassemble the switch. It's really ate up though. I might clean up all the contacts and then move the one in the middle over to this side, because that's just really ate up. Okay, this is the stacker power supply that I was working on that switch. This power supply smells pretty burned. Can't confirm or not, but that might be a 7805 or 7812, being as it's got 5 volts. No, it ain't. Okay. So it ain't a 78. What's this one? Here's another one. Is this a voltage regulator? Can't tell. Some sort of transistor. Anyways, I found something interesting here. Look at all that burn right there. So I think I'm gonna go ahead and take this home and pull it all the way apart and just check everything. Look at that. See what we can find. The cap. Is that a hole in the cap? I don't know. I don't know if that's a hole in the cap. This is probably a big filter cap. What size is this? 400 volt, 330 microfarad. I don't see any bulging on any of these caps. There's some diodes in here that can be checked. But this black box, I believe that's a voltage rectifier. I'm going to check that out. And I have some of these on TV chassis that might be equivalent. Anyways, it's honestly toast. Boss said there was no voltage coming out of it, and there probably wasn't. The rest of these components are probably good, so I'll take them home, take this home, and scope it out with my multimeter. And I bet that this thing's bad, and I bet if it's replaced, this thing will work again. Okay, so I pulled this board out, and she is toast, boy. Look at that. I'm thinking this is a big ground plane. I'm not quite sure. I don't want to scratch too much around here, but it's burnt clear. Alright, this is burnt clear into the fiberglass board. I don't even know where the trace is for this at. There's a piece of solder here. This is carbon track to be hell. I think this is a ground plane. Came over to this cap. I'm gonna do some testing. Yeah, okay, so here's the negative of the cap. The negative's gonna go to the ground plane, and I'm pretty sure it comes over to here. This, and this is probably in the ground plane. Maybe even that. I'm gonna check it with a meter. So this ground plane does come over. You can see the trace right here. That's all backwards. Right in here is copper trace. Probably went around this leg. So definitely at least that trace in part of the board. I mean, this whole fiberglass board has just got a big ass hole burned in it. I'm going to remove this cap because this rectifier is glued to the cap. I think it might be good. I don't get a reading this way, but I do get a reading this way. And that's just the diode itself. But when I add it to this ground plane, I get a 0.6 voltage drop, which should be good for a diode. So I'm going to pull this cap out with this diode because they're glued together, and it'll be easy for me to separate it when it's off this board. Then I'll need to be able to clean up this lag, and I'll have to bare back this trace so I can add in something to connect this lag back to this trace. And I'll resolder in the cap, and then I'll figure out the pin out for the 120 volt input, and then I'll test for the outputs. But I can guarantee it wasn't working because this pin is not touching that trace. Is that a cold solder joint? So this pin here will have to be reflowed. They'll probably reflow all these header pins, and then maybe go through here and check these pins. See if there's anything else that may need reflowed. Okay, have the cap out. Let's give her a little test. It says 290 microfarad. This is a 330 microfarad cap, but it's not shorted. do a little comparison here, just to make sure. Use one of my B+ filter caps. This one says 560 microfarad. $485. Wonder if my battery's getting low. But this cap's not shorted. It's not open. Okay, so we're gonna test these two outside legs. Nothing. The switch. This is a diode. 1.2. We're going to keep the red there. Come to this leg. 0.5 voltage drop. You're going to come to this other outside leg. I need 3 hands. 0.5 voltage drop. Now I'm going to switch the leads where I got those 0.5 voltage drops, and I shouldn't get anything. That means your diode's working. Nothing. Not sure you should get anything between these middle two, but you might. Nope. Okay, so this check's good. What I think happened was probably had a cold solder joint here, and over time it just kept eroding, and then started to carbon track and burnt into the circuit board. As you can see, the fiberglass right here, here's the 4 holes for that rectifier, and you can see where it just ate into the fiberglass from heating up. I was present when this stopped working, and if this would have burned this much at that one point in time, there would have been a smoke show, and there was no smoke. A little bit of burn smell, but no smoke. This would have made some visible smoke. So I'm going to resolder this rectifier back in here, and then I'm going to find some copper wire, and I'm going to wrap around the leg like a loop and run it into this trace that I bared, and then I'll just solder the whole thing in. Okay, here's the repaired solder joint. I took a piece of paper clip and then I basically bent it around the pin right there and brought it onto the solder pad and just soldered the see part of it there. Soldered it together. Should be stronger than the actual trace was, in my opinion. Maybe